Righto, guys. I've been asked to have a go at Chapter 3, 3J, question 16, specifically Part B. I'm going to have to start a bit before that, just so we know what's going on. So I might do all of question 16 for us. It's in the Cambridge Year 9 5.3 textbook. Let's get started. So it says a pilot intends to fly directly to a place called Anderley, which is 240 kilometres due north of his starting point. Okay, so here we've got our pilot. I'll just change that for a darker colour. He's going to fly 240 kilometres due north to a place called Anderley. Let's just represent that with the letter A. The trip usually takes 50 minutes. During a storm, the pilot changes course and flies to Boxley on a bearing of 320 degrees. Well, where's a bearing of 320 degrees? If that's due north, that's on a bearing of 0. So 320 would be around here. So he flies to B on a bearing of 320 degrees. Let me just move that. So that's 240 kilometres there. If that's a bearing of 320 degrees, 320, then that angle in there has got to be 40 degrees. It's got to make it all the way around to 360 for the full revolution. So if that's 320, then that angle in there is 40 degrees. And we're told that he flies, to Boxley on a bearing of 320 degrees for 150 kilometres. And it tells us his speed there, so he does that at 180 kilometres per hour. Okay, it says find to the nearest kilometre how far north the plane has travelled from its starting point. Okay, so what they're asking for now, that's 150 in there, what they're asking for is this distance over here. So let's see if we can get that right angle triangle out of there and have a look at what exactly it's talking about. So that's 150 kilometres. This angle out here was 40 degrees. If this angle out here was 40 degrees, then the angle inside there is going to be 50 degrees because it's got to add up to 90 degrees. And they want us to find out this distance here, this opposite side of the triangle. So it's a right angle triangle. Every right angle triangle trig problem we approach in the same way. We go through the 5 basic steps. Step 1, what sides are involved? Well, in this case, the opposite and the hypotenuse. So opposite and hypotenuse. Step 2 is which ratio uses those sides? Which ratio uses opposite and hypotenuse? Well, the sine ratio does. So step 3 is to write down the ratio. So sine theta is opposite over hypotenuse. Step 4 is to carefully substitute. So sine of 50 equals the opposite over the hypotenuse. And then step 5 is to solve. Because my unknown is on top, then I multiply the 150 across. So x is going to be 150 times sine of 50. Okay, now grab the trusty calculator. So we've got 150 times the sine of 50. That's 114.9 kilometres. Okay, now they wanted to the nearest kilometre, so that's 115 kilometres to the nearest kilometre. Then it asks how far west has the plane travelled? Well, how far west is this distance over here? You've got two options. for working out how far west that is. We know that's 150. We know that's 115, and we know this is a right angle triangle. So we could use Pythagoras' theorem, right? Or we could use trigonometry. Either approach should get you the same answer. So that's 150, and that's 50 degrees. The same answer. Bear in mind that we had to do some rounding off here. So if it's slightly out from one method to the other, that'll be the rounding. But let's use trigonometry. So that's 150, that's 50, and we want to find y. We go through the same 5 steps. What sides are involved? Well, the adjacent and the hypotenuse. Which ratio uses adjacent and hypotenuse? The cosine ratio. We write down the ratio. Cos theta is adjacent over hypotenuse. So cos of 50 is y over 150. Okay, we multiply, because the unknown's on top, we multiply the 150. So y is 150 times cos of 50. We get 96.4. So the nearest kilometre is 96 kilometres. Okay, so 96 kilometres is the nearest kilometre. That's part A. Now let's get on to part B. How many kilometres is the plane off course? Well, what's on course? The plane's meant to be here. So what they're asking for now is, what they're asking for now, if we were intending to get to Anderley, we ended up at what's the name of that other town? Boxley. How far away from our destination are we? So what they're asking for is, what's this distance over here? What's that distance there? Let's think about what we've got and piece together our answers from here into our current problem, and that'll show us what it is we need to do. Okay. So we know that this distance here is 115 kilometres. Let me redraw this diagram a little bit clearer. We know that this distance here is 150. We know that this distance here is 115. We know that this distance here is 96. And we know that this long distance here is 240. We know that this angle here is 40 degrees. Okay. Now let's piece together, and we need to find this distance over here. Let me call it Z. We've already used X and Y over here. Okay, so I'm going to get rid of all this working, and just give us this guy up here to concentrate on. Okay, well, if I was to come along and complete that rectangle there, can you see that because this is 96 kilometres, this is also 96 kilometres? Right? And look at this. If this whole length here is 240 and this length here is 115, well, if that's 115, that's 115, right? Because, I mean, that's a rectangle there, so 115 there, 115 there. So this bit over here is going to be the 240 minus 115. Okay, let's just take this top triangle and bring it down to here with some detail in it now. So now I've got 96 what's that? 25, 125. Okay, I hope I haven't embarrassed myself there. No, that's right. 125 there, and I want to find this distance over here. Well, that's just going to be a Pythagoras theorem question. Pythagoras tells me that the hypotenuse is equal to the square root of the squares on the other two sides. So I want the square root of 125 squared plus 96 squared. That's 157.6. Rounding off to the nearest kilometre is 158 kilometres. Okay. And then look, the last part of that question, question C, is about rates and speed. I'll leave that with you because it's not strictly trigonometry. That is a pretty good enrichment question. I think that's great. I hope you followed. Let me know in the comments below if there's anything I can clarify, or shoot me a question over in Google Teams, in Microsoft Teams. Sorry. Thanks very much, guys.